Well, good evening. Yeah, evening, everybody. Looking at what is it, Tuesday here? Got some wintry weather up there in the Dakotas. Let me get rid of this little overlay here. There we go. Yeah, blizzard up in North Dakota there finally came together, and one good way we can see just how widespread the blizzard conditions are is on traffic maps. There's no traffic there on I-94 there, and also that north-south one to Winnipeg, that appears to be shut down too. So what does that look like on the surface charts? There's our low-pressure area right there, and maybe I can bring up the, let's see. Yeah, let me bring up the, no, never mind. I was going to bring up the fronts real quick, but I really don't want to mess anything up here. But this is a typical presentation of blizzard conditions. You're going to find those on the backside of very deep, low-pressure areas with tight gradients. And you can see winds there are sustained about 20 to 30 knots. Now, this snow is going to be kind of dry, but dry snow has a prolific ability to pile up. So you can get some huge drifts on the road surfaces there, and that can really mess things up there. Now, when I was talking about bringing up fronts, I was going to bring up the NOAA Weather Prediction Center depiction of frontal boundaries, but I can just kind of paint this on myself. It looks like the main baroclinic system on this low-pressure area is way to the south. And we're talking probably, let's see, it's already cleared Georgia and western Florida. So probably our low-pressure area down to the south is way down in the Carolinas. And I think we're probably looking at a bit of a occlusion coming back northward. Now, I really do need to kind of look at the data to see if that's supported. A lot of this is going to depend on the jet stream positioning. Maybe I can do that real quick. Let me head over to our. This is our 500 millibar chart. I'm going to set this on today's plot. Okay, so where's our jet stream energy? Looks like we've got two jet streams in place. There's one coming in off the Pacific into Northern California right there. And the way I'm finding this, I'm looking at the wind flags. These wind flags, like you see here, that's 50 knots. Because they've got that strong pennant there. The weaker ones, this would be 25 knots. And when you have good mixing of the long pennants, or the long barbs and the pennant, that's going to be 85 knots right there. Also, I'm looking at the channeling, such as between the red and the very bright colors. That's a vorticity channel right there. So that's going to be associated with jet stream energy. So this is probably our main polar front jet area. This up here, this could be a polar front jet too. The way we can try to isolate that a bit is to look at the 300 millibar chart. I'm going to pull that up very briefly. And let me crack open a LaCroix here. Haven't had anything to drink this evening. Okay, so we're going to try to find the subtropical jet and go a little bit higher in the atmosphere. And see what I'm doing here. I'm kind of getting an idea of the outlay of upper level energy and try to figure out where these patterns are, because this is a reflection of what's happening at the surface. Okay. So there's our 300 millibar chart. And here we can see the subtropical jet. See this thing coming out of Mexico into South Texas? Got 100 knots right there in the San Antonio area. And this 110 knots here through Georgia. So that's our positioning of the subtropical jet. And that's one reason they have severe potential down there, because when you have very strong winds aloft, that gives you good separation between the updraft and downdraft, and good ventilation of the updraft into the anvil. We haven't had a whole lot of that severe weather today, very fortunately, because the instability just hasn't been there. But in terms of wind and shear, that's been pretty decent. Now I'm going to step down to 300 millibars, because 200 millibars, that kind of gets up into the stratosphere this time of year, and it gets very complicated using all these different charts. Whereas in the summer, you can just throw up 300 or 250 and be done with. So now I'm going to go down to 300 millibars. This is up at about 30,000 feet. Let me set that on tonight's chart. And now you can see that subtropical jet a little bit better. See, there it is over the southeast U.S. And now we can see the polar front jet. Yeah, that's coming in through Nevada. And looks like it picks up a little bit in Oklahoma. And then there's another segment way up here in Maine into the Great Lakes. So you might be asking, what does that tell me? Well, the polar front jet tends to be more tied into surface systems, whereas the subtropical jet, that's more associated with processes aloft, upper fronts, and that kind of thing. So, of course, that's not the final word on this, but I would suspect that we've probably got maybe a cold front kind of like this, and that ridge right here in the northeast U.S., that's probably supporting a warm front, something like that. And then we go north from there. That gets into that blizzard, and that's going to be the occluded front. So you can see I'm kind of tying everything together and looking for vertical consistency. And I can see that this ridging over the northeast U.S., that's being supported by the warm air advection moving northward to the east of that frontal system. And then this large long wave trough here, that's a consequence of the strong cold air advection taking place in the central U.S. So you can kind of see what's going on there. And that helps put the surface chart a little more into perspective. I'm still not totally sure what's going on in this zone. I would want to spend more time looking at soundings and maybe doing some cross sections and wind grids. But in any case, we know that that blizzard is in a occluded area. And that's going to be a region of barotropic cyclone, I guess you could say. There's very little difference in the temperature. You can see we've got 32 here, 29, 24. Got a little bit of cold air here, 17, but the temperatures are pretty homogeneous all the way around this low pressure area. So we don't have that baroclinicity that helps with development, and we're going to expect to see this gradually start to weaken, at least in terms of the pressure gradient. So we should see the blizzard kind of tapering off over the next day or so. I can see some activity on chat, so let me look over here and make sure I'm not forgetting you guys. Some discussion here. Robert Archer is talking about lake effects. Illinois, Indiana. Okay, in detail. Okay. Other questions? Let's see here. Snowblower, so excited. And got some folks in Indiana, northern Indiana, lake effect snow. Okay. Yeah, we'll touch on that just a little bit. This time of year, this is the early winter, and the lakes, they still have some warmth this time of year. They are kind of shallow, so they lose that pretty quickly. So you don't have lake effect snows in the late part of winter very much. But this is kind of like a big reservoir of moisture and heat, and that's going to destabilize any cold air that's streaming over the lakes. So you have this cold air mass coming over Wisconsin and across Milwaukee. Then it crosses the Lake Michigan area and picks up moisture and heat. So you develop these convective cloud bands that stream into Michigan. And it really depends on the wind direction, who's picking up the snowfall. So when this low pressure area moves to the east, we'll see the surface winds turn more northwesterly, and that can start blowing some lake effect snows more towards the southeast. So South Bend and even Gary. They can see some lake effect snows. And in the rare instances where we get northeast winds off the lakes, Chicago can really get it there. Other areas that really get lake effect snows, Buffalo, of course, you probably remember them in the news for getting multi-foot snow accumulations. And that can be due to southwesterly winds coming up straight up Lake Erie like that. So basically, when you're living near the lakes, you're paying close attention to the wind direction and the lake temperatures and the temperatures in the mid-levels of the atmosphere, because that's what sets up your steep lapse rates. So anyway, yeah, enough of the blizzard. I mean, it's fun to look at, but I don't want to stay here for 30 minutes talking about that because we got a lot to cover here. Northeast U.S., there's an old high-pressure area right there. And down to the south, that system that came out of Georgia yesterday, that's moving on up the east coast right there. And behind it, some very weak cold air advection, not much power to that system back in the back behind it. So temperatures still in the 50s and 60s in Georgia and Carolina. They're just not getting that cold air just yet. Further west in Texas, let me get this moved over. We've had a front come through today across all of Texas. It started up in Oklahoma last night, and at this time right now you can see it off the coast of Texas, entering northern Mexico right there. That air in the behind the front, not very cold at all. We're looking at just 40s and 50s there. And we've got this 10-20 millibar high pushing that cold air southward. So that's kind of a mild push of cold air. Up to the north, what do we got? We've got more cold air on the way south. We've got a 10-35 millibar high. And if we go all the way into Yukon in the Northwest Territories, you can see we've got this 10-52 millibar high. And there's an old rule of thumb that whenever there's a 10-50 millibar high in Western Canada, you can pretty much expect that cold air mass to make it all the way down to Texas eventually. Because 1052, that's getting towards about the highest that you will ever see. I think the highest I've seen period is about maybe 1062 millibars. So that's definitely some serious high pressure. And that's being caused by very extensive and deep cold air in place over Western Canada. So a lot of times in this time of year, you'll have a lot of minus 20s and minus 30s, but it'll be very shallow and you'll have like 0 to 10 just off the surface. Not in this case. You get a loft and you still have minus 20 and minus 30. So that makes a huge difference, and that's what's going to give you very strong, deep cold air outbreaks that make it into the central U.S. Okay, maybe one other thing I can show you to give you some idea of what's going on. University of Wyoming soundings. Yeah, let me do UCAR. I've got a special link for that. If you guys feel like it, you're welcome to use this weathergraphics.com/WX site. That's got a bunch of charts. I haven't really updated it too much recently in the past few years, but you might find some stuff on there that you like. And one source that I use is the UCAR soundings. And we can pull up the Oklahoma City sounding and kind of see what's going on here. This is the Norman sounding taken an hour and 15 minutes ago. This is showing cold air moving through Oklahoma. It's not very cold, but it's very deep. This is unusually deep for a mild air mass like that. You can see it's extending all the way up to about 6,000 or 7,000 feet. Then as we get further north into Dodge City, the cold air tops out at about 11,000 feet right there. Then we get up to North Platte, Nebraska, and I think it's gone even higher. I think we've kind of lost it there. think that's north of the troposphere fold right there, the tropopause fold. Bismarck. Yeah, I think that's back further in the cold air, and I think that's some Arctic air coming south. Let's go all the way into Edmonton, and you can see what some really cold air looks like right there. This is way back in the polar air. It extends all the way up to 30,000 feet. So you can see up at that level we have minus 30, minus 40, minus 50, almost minus 60 at 300 millibars. So airplanes flying at that level, they have to be very concerned about the jet fuel freezing on the airplane because of it. The tanks are not heated, and jet fuel freezes at minus 40. I think Canada uses Jet A1, which freezes at like minus 47, but it takes time for jet fuel to freeze. But they do have to kind of pay close attention to that, especially on transpolar flights. So, yeah, very, very cold air aloft. And that's what's a big factor in these air masses coming southward into the U.S. Okay, I guess we'll move forward and let's see what other charts I have lined up. You can see the blizzard warning in effect for North Dakota right there and parts of Minnesota. A lot going on. And yeah, I wanted to compare this. Just the other day I was looking at the longest blizzard ever recorded in Canada. That was back on January 18th through about the 22nd or 23rd. This was in a town in Nunavut called Rankin Inlet. And I don't know if any of you have heard of that, but this is Hudson Bay, located right there. And there's Quebec. Nunavut is located right there. And what you're seeing here is the day before this blizzard started. They had a blizzard that lasted for 7 days, and that set Canada's all-time longest record for a blizzard. So what happened here, if I draw the fronts, there's the frontal boundary. It's kind of north-south through here. Not too sure where the warm front is. I think maybe there's probably an Arctic warm front up here. But anyway, you can see temperatures here, minus 13 Celsius at Rankin Inlet. That's about 10 Fahrenheit, which is kind of warm for them. But you can see back to the west, very large, strong pressure gradient and very cold temperatures to the west. A lot of minus 35, minus 33 Celsius. That's in the minus 25 to minus 35 Fahrenheit range. So what happened the next day? Well, that cold air hit Hudson Bay and underwent development and got a big low pressure area, and the pressure gradients tightened in the Rankin Inlet area right there. And you can see them there with minus 31 Celsius, which is about 26 Fahrenheit, minus 26. So that coupled with 30 to 40 knot winds, that kicked up a whole lot of dry snow and just cut visibilities down to zero for days on end. And this pattern kind of stayed in place for the next several days, and you can see the flows coming from the north. So if we look at trajectories at Rankin Inlet, you can see they're coming from the north. So the air parcels kind of came from the Canadian high Arctic, and that gave them kind of an Arctic outbreak of their own. All right, I guess it's time to head into the forecast. So let me get our map centered here. Get that blizzard in the window. You can see it, the low pressure area right there over southwestern Ontario, and a lot of wraparound on the back side, because the main upper level low is located well to the west. So you still have an area of upward motion just off the surface, back behind the surface low. And that's what's happening here. And notice the very strong pressure gradients there in Minnesota and North Dakota. Now further down in Texas, you can see the thickness gradient that's in place, and that's supporting the front, which is well down to the south. But also keep an eye on this area. You're going to see this thickness gradient tighten up as the next front develops. So we'll move forward into tomorrow. And when you join us for the webcast tomorrow, you can see tightened thickness gradient right there. So this is an area of frontogenesis in Oklahoma and North Texas. So we've probably got that as a response to some upper level energy coming in from the west. And then you can see up in Minnesota, we're starting to get the pressure gradient relax a little bit over Minnesota. Then going into our webcast for Thursday, this is the picture. Looks like we missed some detail. Yeah, it looks like some of that Arctic air has come southward, and we can see pressures in Texas building from 1030 millibars up to 1040 millibars. So a lot of the cold air is starting to push south. So we should see a pretty cold day here for much of the central U.S. And you can see things start to improve over the Great Lakes, but still some lake effect snows. And the wind directions do turn a little bit more from the north. So we should see some of the snow bands starting to come south off the lakes. Starting to get a little bit of development out in this area on the western periphery of the polar air. Then when you join us for Friday's webcast, here's what we're looking at. A little bit of warm air advection over Texas, but things are starting to get kind of busy out in this area. For Saturday's webcast, yeah, see that here? New system coming together and plowing right through the polar air in Wyoming and South Dakota and Nebraska. So if I draw out the fronts, we're going to look at something like this. So that's the next system coming through. And as you've learned from this webcast, the backside is what we really have to watch for blizzard conditions as that low pressure area emerges. And there it goes. And so for Sunday, not quite as much of a blizzard condition in Minnesota and Iowa, but still some pretty strong gradients back here. And here comes our next front coming southward into Texas. And this system is heading off to the northeast U.S. And then for Monday next week on the 12th, here comes some more Arctic air from the north. Probably a bit of a stationary front right there. And lee side trough through New Mexico like that. So it looks like a lot of lift back north of that front. So probably some snow showers there in Nebraska. And next front plunges southward on Tuesday. There it is. And then we go forward into Wednesday. More cold air on the way south. Then for Thursday, 1040 millibar high sinking into Missouri. And things start to get active once again out in the northern Great Basin. So this is some fun weather to look at. Things are finally starting to break this these doldrums that we've had. Looks like another winter storm for the Midwest there on the 17th through the 18th. And now things are starting to get a little bit fuzzy since we're getting out to the 300-hour point. But basically we're seeing kind of a continued succession of polar and Arctic outbreaks pushing south. And then I think towards the end things are going to get a little bit more zonal, a little bit more west to east. You can see the thickness lines up here. They've got an orientation kind of like that. So that tells me things might be getting a little bit more zonal with systems coming more out of the Pacific. Okay. I guess you know what that music means. We're probably about done here. Let me check through the chat and say hello to everybody. And I'm probably going to have to read a lot of this after I'm done. But yeah, a lot of discussion about lake effect snows there. So yeah, if you're not watching this live, you'll probably enjoy the chat if you drop in during the live cast and say hello to everybody and talk weather and have your questions answered. Anyway, thanks for watching. I appreciate you tuning into the webcast, and we'll see you tomorrow.